Hi guys, you got Nick Berry here from Seed Terminator. We've got a John Deere S680 combine here, and I'm just going to run through what we have done to upgrade the chopper drive line to attach the Seed Terminator to the machine. So this machine already has a 4-groove pulley, 4 C-section pulley on the engine PTO, and that's designed to adapt for the 100-blade chopper, and it actually comes with a 3-rib belt on the standard chopper versions. So we can actually buy the 4-rib belt for the 100-blade chopper and replace the pulley down on the jack shaft with the 4-rib pulley, and then we can actually upgrade that drive to be able to handle the additional load of the Terminator and a standard chopper. On the 670, S670 and S770 machines, they only have a 3-groove belt pulley at the top here. So we do need to upgrade to the S680 or S780 pulley up here, and that's a John Deere standard part as well. So a question might be, well, can the engine PTO handle the additional load of the Terminator? And I guess the simple answer is that we've had no clutch failures so far, 4 seasons in on John Deere machines. The gearbox is clearly designed to be able to handle the load of a 4-groove belt, so it makes sense that running the 4-groove belt wouldn't affect that clutch, and so far we haven't seen any issues on that. So customers can take confidence that these are standard John Deere parts that are adapting to attach to the combine. So we've got our 4-rib belt down to the 4-groove pulley here on the jack shaft, so we've got additional power now to this pulley on the inside here. On a standard machine, we would have a high-speed chopper drive belt and a slow-speed chopper drive belt and a gap between them. Now, what we do on these machines, and have done for the 4 seasons we've been operating for, is we actually use the slow-speed drive side of the chopper jack shaft and go directly to the Terminator. And that delivers us power to the Terminator and to the chopper. The thing about the position of this slow-speed drive is that because it's as far inboard as that we could possibly get, so the gap between the chassis and this belt driver path is as close as possible, we actually get the maximum steering clearance we can possibly get. And this is critical on 3-metre tramline machines that are set up on the 3-metre tracks, because this steering angle becomes quite tight. So even with it close as possible here, we still need to restrict the motion somewhat, but on some other machines you'll have to move the steering angle further out. So on the John Deere in particular, you're able to get good turning angle with the 3-metre centres and basically limit the effect on the harvester. Attaching the belt drive off of the jack shaft here, we don't add any additional load to the chopper bearings. So if you can imagine, what's happening here is that we've got belt pulling this way and a belt pulling this way, so the jack shaft load is not increased significantly because the belt pull is opposing each other. If we were to drive the belt down to this chopper and then off of the chopper, then all of a sudden we've got a lot more load on the chopper pulling it this way and loading up the chopper knife bearings. So coming down to the Terminator, what we have here is we've got a double C-section belt down to the Terminator gearbox. This is a German manufactured gearbox which is using high performance spiral bevel gears in there. So it's a highly efficient gearbox. It doesn't have any cooling system whatsoever on it. So what does that mean? Well, that means that we're not creating heat, which means it's highly efficient. We're not losing power to hot air. That gearbox transfers to a belt path underneath the mills. And the reason we do that is so that we've got a belt going to each individual mill. That means that something happens to this mill, it's independent of that one, and the gearbox is independent of both of the mills. So if something hard went in here, it wouldn't jar the gearbox anywhere near as much if it was directly connected with shafts or with a rigid connection. So we've got ability to slip there. And the other key factor is that because we've got the belt path, we can actually speed it up. The gearbox is spinning at 1580 RPM and the mills are spinning around 2950 RPM. So we've got a nearly double speed up, and that means the gearbox can run cool. We're not splashing the oil around in the gearbox to create heat, and therefore the design is as efficient as possible. So we've got the gearbox that changes the direction of the drive across to the two mills. The two mills spin in the same direction. That means that the parts in the left mill and the right mill are common. So you only need to keep spares of one style. Left and right are identical. The horizontal arrangement enables us to actually access each of those mills easily. So it's a quick change out for screens and rotors and flails, because they are open, so you can actually access everything.